Hi everyone, welcome to lesson 7 today of our trigonometry unit. Today is applications of sine and cosine functions. Basically think of this as our word problem lesson. We have 4 examples to get through today, so let's get going. The very first word problem we have is the height of a rider on a Ferris wheel given by this function. So we have this function. Notice here we have a pi in our function, so automatically I'm thinking radian for mode. I'm thinking radians for mode there. Where ht is the height of the rider after t seconds after the rider gets on. First off, they're asking you what are the maximum and minimum heights of the wheel. So to figure out max and min, one of 2 ways to do this. Option number 1 right away is you can graph this equation and then you can figure out your max and min. Option 2 is to run your equations for max and min, and that would also work. The equation for max and min, of course, uses your a value and your d value. So again, that's a and this is d, and that's going to help us find our max min. So to find max min max, let's start there first, is a combination of your d value, vertical displacement, plus your amplitude a value. In this case we have 12 plus 10, so we're looking at a maximum of 22. And again, it'd be the height here usually in terms of meters. Your minimum value is going to be equal to d minus a. And again, our d value is 12 minus a, which is 10. So our minimum value that we go on this Ferris wheel is 2. And that does kind of make sense in terms of a Ferris wheel. You don't want your minimum value to be at 0 because that means your Ferris wheel would have gone right into the ground there. So there must have been some sort of stand or a height or something to get onto the Ferris wheel 2 meters off the ground. Again, you could have seen this right off of your calculator if you'd set up your window setting. I'm just going to quickly show you what it would look like on a graphing calculator. So here we go. So here's my calculator. I have an equation of 10 sine, and to type in this pi over 30, you can either use your fraction function, which I do, or you can use just pi divided by 30. Don't forget you should throw brackets around it because it is a fraction. 30 in our denominator there. And instead of t, we're going to use the variable of x here, x minus 15. And then we got close plus 12. And there we go. So this is our equation that we have. If I graph it right away, I'm in the wrong window setting, so I probably want to play around with my window setting first before I hit graph. Again, we don't know how long this is going to take for this ride, but notice that it said t minus 15, so you should at minimum have an x value greater than 15. I'm going to go to something like 100 there, go up by 10 because that includes greater than 15 on your x. Your y values, again, your minimum we just found out earlier was 2, but what if you didn't know? If you didn't know, I would have left it at 10 here. But I do know a d value will start at 12, so I know I needed a y max greater than 12. If you doubled it there, you would have been good, but really that's kind of overkill for this question, but doubling it would have been fine, and 1 there. Again, just to show you, I am in radian mode. So here we go, let's hit graph, and there you go. That is my curve, and that's basically our Ferris wheel. You start at the bottom, you go to the top, go back to the bottom, go top. So that's the motion of a Ferris wheel. To find your max and min on your graphing calculator, just go second, trace, and depending on which option you're looking for, minimum, maximum, let's do a max, and then it's going to be the same thing for a min. So, but we're going to find our first max. So finding our first max, you're going to go left of where that first max is, go right of where you think that first max is, then go to where you think that max is. That's going to be your guess, and there you go. Our first max is at 30, y equals 22. So really it's our y value that's going to get us our max min value, so 22. And again, if you had done the same thing to find minimum, you would have had minimum value of y equals 2 there. So again, 2 different ways to do this. I like using the equation. I also like sketching a quick picture as well. So if that was my grid there, and I'm just going to draw on a quick sine curve, it looks like. So sine curve here. Again, I'm not going to do it anything proper with phase shifts or anything, but I know that it said sine curve, so here's my sine curve. My amplitude would have been 10 right there, and that distance would have also been 10 right in there as well, if that was my amplitude. And if I had my d value would have been that middle line cutting through my sine curve at 12 there. So then to find the max and min, if you started off at 12, you're going to add 10 more, and you would have hit 22, and you would have subtracted 10 more, and you would have hit 2. And so again, that's our max and min if you want to visualize it that way. After, for part B, after how long after the wheel is at its lowest point does it reach its highest point? So again, we kind of just found that out here. So its lowest point here would have been at the start here. That's at 0, 2. And again, you're 2 off the ground there. And it took, and we already did this, so previously we found our first max. And it's going to take about from 0, 2 to 30, 22 to get to the max there. So really, we're looking at the coordinates of the following. So we're looking at the first coordinate 0, 2, and we went to from, and that's the lowest, and reaches its highest point at 30, 22. So you have your minimum, you have your maximum. How long did it take? Well, it clearly took from 0 to 30 seconds, which is therefore just it took time equals 30 seconds to go from your minimum to your maximum, or your lowest to your highest. In part C, how long does it take the Ferris wheel to make it should have said one revolution to make on revolution one. It's missing the letter E there. So what is one revolution here? So if you had a valley here, you're looking for the next possible valley. It's right here. So again, this first valley was at 0, 2, and again, I'm just looking at 0, 2 there. I'm just looking at that x value because we're talking time. Okay, so we're talking time. So I want to find that value there. That's a minimum. So second trace option 3 for minimum. Go where you think it's to the left, hit enter. Go where you think it's right of it, hit enter, and then kind of get right on it. And there you go. You get 60, 2. So really, it took you from 0 to 60. That's going to be how long does it take to make one revolution? Our period is basically 60 seconds. So I'm going to write down one revolution equals 60 seconds to answer this particular question. And again, that 60 seconds is your period. Your period is every 60 seconds, it's going to repeat itself. During 1 minute of the ride, aka 60 seconds, at what time after the rider gets on is the wheel at its height of 20? So you could change up your window settings, but I know that in 60 seconds, basically in 1 minute, so it's between 0 and 60 here, we're looking for height of 20. So what I need to do is go into y equals, go down to y2, type in 20 here, hit graph now. And so you see this line here, it's going throughout the entire graph, but really again we're stopping at this first valley. So where does it cross our graph? It crosses our graph in 2 positions, so we're going to go second trace option 5 and find out what those 2 answers are. So I'm just moving my cursor to that first one there, enter, 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 and there you go. Our first position is 23 and 20. The second position, let's find that, second trace option 5, enter, 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 36, 144, and 20. So basically you have 2 positions where your rider reaches a height of 20 meters. So your times during 1 minute, and it doesn't tell you how many decimals to round to in this case here, so I would have rounded to the first decimal there, so 23.9 and 36.1 in terms of time, so in terms of seconds there. In example 2, it says the depth of the water in a seaport is given by this equation here, and again I notice pi, so I want to be in radian mode, where t represents the hours in a day and d represents the meter. So it's basically depending on the time of day, your seaport is either rising or falling based on the water there. So the first part here is asking you, what's your window setting? What window setting would you be using? What's your period and what's your range of this question? So my period that I'm looking at here, Um, or sorry, my window setting before I do my period and range. My window setting here, kind of tough to tell what it is. Let's just, well, I know at minimum for my y values, I'm starting at 13.4, and I want to add 2.5 minus 2.5, so I'm probably somewhere in the ballpark of higher than 15.9. Round up, it'd be about 20 there, the lowest you want to go. You can go as low as even 10 even, because if you went 13, 4 minus 2.5, that's 11, like 10.9, almost in that ballpark. I'd just go a bit lower. But yeah, so let's right away graph it on our calculator and see what we get. Again, clear off our old stuff there. So I'm going to just type in the equation as is. So 2.5 sine, and I have, sorry, 0 0.2, oops, 0 0.2 pi. And that was outside of a bracket, so be very careful. Add another pair of brackets here. T is now x minus 1.5. Close, close. Plus 13.4. Kind of long, but yeah, that should work. Again, our window setting that I want to check, I probably want to check something like in the negatives a bit. Let's go to, let's start off with the positive 10 going up by 1 there for our x's, and our y's. I know I want something reasonable. I probably don't need to go below 0, so I'm going to go 0 as high as, well, I only need it really basically higher than 15, so I'm just going to go to about 16 there. Going up by 1s is perfectly fine, and let's hit graph right away. So we do see our graph here. I definitely could cut down on the amount of y's there. I do want to shift over a bit more to the x's there so that I could see maybe another peak. So again, I'm just going to change my window setting here. Let's go to something like 25 there. And our minimum value, we really don't need 0. I'm just gonna go to 10, and there you go. That kind of looks a bit more filled out on our screen, and that's perfectly fine. However you want to do it, as long as you can see something on your screen there, you're good. So my window setting in this case here, in this example, all I do is copy down my window setting. So I went from negative 10, 25, 1 for my x's. So I'm going, really you could have gone from 0. So I could start off at 0, 25, and 1 for x's, and I'm starting at 10. Did I go to 25? I honestly can't remember. 10, 16, and 1. 10, 16, and 1. So, yep, graph still looks good. 10, 16, and 1 there for my y value. Period, let's find our period. Here, by the way, this is our b value. So period is equal to 2 pi divided by absolute value of our b, which is 0 0.2 pi. And when I divide that off there, that equals a period of 10. My b value is 0 0.2 pi, but I have a period of 10. What's my range? Well, what's our lowest, what's our highest? And that, again, we just want to find. So the lowest is 10.9, and our highest was 15.9. There we go. Square brackets because we want to include both. So this first question here, part A, what is the depth of the water at 9 a.m.? So at 9 a.m., and again, T represents hours in a day. So really, if it's hours in a day, I'm going to go to 24 hours a day, going up by 1 hour a day. Everything else looks good so far, and again, that's my graph. If I'm looking at 9 a.m., just simply hit trace 9, enter. So this here is going to tell you at 9 a.m. you got to 10.9 for a height there, so 10.9 meters for a height. You could have also gone second, graph, and brought up a table of values, and that would have worked as well. My table is slightly off, so I'm just going to fix my table. I want to start at 0, going up there by 1 for 1 hour each. And again, at 9, we're looking at 10.9. So two different ways to find a part A here. So I'm going to write down my ordered pair. At 9 for x, we are at 10.9 for y. So therefore, at what depth of the water? Depth of the water is equals 10.9 3.9 meters at 9 a.m. At what time during the day is the depth of the water 15 meters? So if we're looking for 15 meters, you're looking on your Y for 15. Well, look right around there. It's around 5 and 6. Well, I want to be a bit more accurate. Go Y1. Sorry, go Y equals Y2 you want as 15. Gonna hit graph. There we go. We have a few different times that it hits this height, 15 meters, and so you just want to go second trace option 5 and find all of them. I'm going to start on the very far left and work my way right. So the first one, 2.6, 2.61, really. It doesn't tell you how many decimals to round to. I'm just going to round to maybe 2 decimals each here. So time is equal to 2.61. That's the first one. Then second trace option 5 again. Enter 3 times, 5.39. Second trace option 5 again. We got 3 more to go. And if this ever happens to your graph where your cursor is just following that line and you didn't want that, you can hit your up and down arrow to switch between graphs, and that might just speed things up. 10.61, or sorry, 12.61. Uh, 1539. And last but not least, it should be 22.61. But let's use our graphing calculator to get there. There we go. Enter, enter, enter. 2261. And remember, these are all times, right? So these are all times. Like 2 would represent 2 a.m., 5 a.m., 12 p.m. lunchtime. 15, there's basically, if it's 15, we're talking about 24-hour clock. So that's about 3 o'clock there, and this is about 10 o'clock at night there. Okay. For part C here, we have how long is the depth of the water greater than 12 meters in the first 12 hours. So we want to set up our Y2 instead of 15 this time. We're setting up at 12. And if you want to change your window setting because it wants to see it in the first 12 hours, so my X max, just 12 there. Hit graph and let's see what we get. So we got something like this. So I'm looking for 3 answers because we crossed 3 times. So second trace option 5 there. And again, I hit my up and down arrow because I want to move my cursor, and sometimes it's a bit faster just moving it linear. There we go, our first one here. So really quick, our time here is 0.55. So for how long, depth of water greater than 12. So we're greater than 12 starting at 0.55, and then we need to find this one here. So second trace option 5. So we're greater than 12 all through this entire section until we get to this right here, which is 7.45, basically 7.45. So from 0.22 to 7.45, you're greater than 12 meters. So greater than 12 meters. But then we also have, if you notice, we have this section here, so let's find that. So second trace option 5. And we want to find this. Enter, enter, enter. 10.55. So the next time interval would be from 10.55. Oops, wrong color. And where would it stop? Well, it's going right to the edge there, so we're going from 10.55 to 12. And during this section, it's also greater than 12 meters as well. And that's example 2. In our next example, we have a Ferris wheel again, so it's very, very similar to lesson 1. Has a radius of 10, it rotates every 40 seconds. Passengers get on at the bottom, which is 1 meter above ground level. Suppose you get on at the bottom and the wheel starts to rotate. So what do we need to know about this picture here? So I got a picture of a circle here and a grid here, Okay, so the first things first, I'm gonna find where halfway is, draw a line straight down basically. I have a line function and I should have just used that. And what this is representing is, oops, that looks like about right. What this represents is, you know the radius is 10, so I'm going to jot down 10 in our picture here, so that's 10 meters this radius. But then there's also right down here it says which is 1 meter above ground level. That's at the bottom. The passengers get on right here, so if you think of a passenger getting on there, so again here's the bottom, and this here, that distance there is 1 meter distance. Okay, so if you were already up 1 meter and then the middle is 10, so in total your distance right now is 11. 11. So the question is, if you were 11 halfway, how high would you get to on this Ferris wheel? What's the highest point of this Ferris wheel? Well, if you drew a line straight down from here to here, and of course this is still your radius of 10 meters. What are all your heights? So right now this is going to be 1 meter off the ground. Right here, this height here, 1 plus 10 would be 11 meters off the ground in total. And then right here at the top, you would be plus another 10, so you're 21 meters. So this picture here kind of helps you figure out, well, what should your y values be? Okay, so you know there should be a gap between 0 and 1 because you get on at 1. It's going to be halfway at 11 and reach its peak at 21. You also know in this question here, it rotates every 40 seconds, and that's key, every 40 seconds. Every 40 seconds, that's your period. Equals 40 seconds. So therefore, what's your b value if you ever had to make an equation? Therefore, b value is equal to, and because this is a word problem, we usually do everything in terms of radians. So my b value is going to be 2 pi over 40, which is the same thing as saying pi over 20. And that's how I'd get a b value. And I can input that into an equation. I'm going to sketch out a picture here, and that's what it's asking you. Graph the height for the first 2 cycles, sure. So I'm going to draw a line here, and this line's going to help me figure out where 1 is, because that's basically our new bottom. Okay, so this here, this line represents 1 meter off the ground, and this graph is not going to be accurate by any means. About halfway up this line here now, that looks like it's about half. I'm going to draw another dotted line, and this time this dotted line, this is my vertical displacement line, and my vertical displacement starting at 11. So again, I have 1 here, 11 here. So at the top, let's draw another line here. Let's pick a different color. Yeah, let's do something like a red. At the top here, what this red line is representing is the max, the top that our Ferris wheel can go, and of course the top off is 21. So here on the side, this is all our height. So we have our time here on the bottom, and it says that it rotates every 40 seconds. So right now I need to divvy up this bottom into about 40 seconds, and it's looking for the first 2 cycles. So if I kind of cut this right in half, right around here, that's, I'm going to label as 40. The next half here, let's label that as 80, because that's going to be 2 full cycles. Well, halfway between 40, I have 20 here, and halfway between 40 and 80, it's going to be 60, and that halfway is kind of important because that's going to be at the peak. I can half of this guy here, that's 10, that's 30, 50, and 70, and all these numbers I just wrote in are just going to be a bit of extra info. So if I had to put down a few coordinate dots, it'd be the following. So you get on the Ferris wheel at 0, and this is me graphing without anything. I know I get to the bottom again at 40. If I did another full cycle, I would have gotten to the bottom at 80. So I got 3 dots on my first line here. I have 0, 40, and 80. I know that halfway up, I should have been between 0 and 40. Halfway was 20. I should have been at my peak, should be at my max there. Between 40 and 80, my peak here, my max here would have been around 60. So that means at 10, I should have been halfway up, and at 30, I should have gone halfway down. At 50, I would have been halfway up, and at 70, I would have been on my way down, halfway down. There we go. And this is more or less enough information to sketch yourself a very rough draft of our graph. And so mine's going to look something like this. And yeah, my picture here is very rough sketch. That's really all it's asking you to do is do a rough sketch, because it didn't give you a grid or anything here, so you're just gonna try your best. Oops, and I totally missed that coordinate there, and there we go, close enough. Okay, so that's our graph, and ultimately when you build an equation, you want to match it up to that graph there. So part B, write an equation. Right away, write an equation. So let's fill in some of our variables. So A, amplitude. Well, what is our amplitude here? Well, our amplitude is our radius. So we're fluctuating between 10 and 10. So our radius is 10, so our amplitude has to be 10. Our vertical displacement is what I find next after I have my amplitude. My vertical displacement is going to be right in the middle there. It's that line that cuts your graph right in half. My vertical displacement is going to be at 11. We had our period, it did mention it in the question as 40 seconds, so therefore our b value is equal to 2 pi, again divided by 40, which we will reduce down to pi over 20 for a b value. And last but not least, phase shift. Well, do you have a phase shift? Well, you could have a phase shift if you're looking at a sine curve. Sine curve would have started off here at 10, gone up, gone down, and ended here at 50. So that could be a phase shift. So you shifted it 10 to the right. If you wanted a sine curve, you could have used a cosine curve. That means you should have started at 20 to the right. So it starts from top, going all the way down, back up to the top there. Okay. So for your phase shift, you have a multitude of answers here. It depends on what your graph is going to look like. Okay. So I'm going to write down a sine curve. So that's going to be my first go-to sine curve. So let's write it in terms of our equation. So we got h, I believe it's h of t, because we're talking time there. So I'm going to go h of t, height and time, is equal to, well, again, a value is 10. I said the first one's going to be sine curve, so I'm going to go 10 sine. My b value is pi over 20 of x. And the first one here, I do have a phase shift. Let's start with a standard sine curve. So we're going to shift it 10 to the right to start there. So it's going to be x minus 10, bracket, bracket. And we're going to go plus 11, and that's our vertical displacement. So that's definitely one equation. Second equation that we could have wrote, and I would have had to accept, could have been something like, let's do a sine curve. So again, everything's all the same. So 10, but this time we're going to use cosine and have a different phase shift. So pi over 20, x minus, and it would have been starting off 20 to the right, so 20 there. So I got rounded bracket, square bracket, plus 11. So that's going to be my next equation. I have a positive sign, I have a positive cosine, so I've got two different versions right now. I could also do a negative graph, so if I had h of t equals, this time let's go negative 10 sine, so I'm doing a negative sine curve, pi over 20. My phase shift here, because I'm starting right at 0, it's going to be nothing. Oh, sorry, this isn't my sine curve. If I'm starting at 0, this would have been my cosine curve. My apologies. Let's write down cosine. Oops. Cosine, there we go. It's just x right there because there's no phase shift, plus 11. So if you had a negative cosine curve, so valley to valley, that would be this one here. Negative sine curve, sorry, my apologies, would have been starting at 30 to the right. So it would have been gone down, gone up. So 30 to the right. There you go. So you have uh, quite a variety of solutions you could have chosen to express your equation, and all of them are perfectly fine. Find the height above the ground after 15 seconds. So if you had your grid here, 15 is just halfway up, so you know it's going to be higher than 11. Go to your graphing calculator. Let's type in one of these equations and set our window setting proper, and then we should be good. So again, let's choose just any of the equations. It's perfectly fine. I'm going to go with the negative 10 just because we haven't done this too often. Negative 10 cos um, alpha y equals option 1. I got my pi over 20. Oops. Let's type in pi. There we go. Pi over 20. Um, and you had just x there, no phase shift, so close, plus 11. So I do want a window setting lowest is 0, let's say, because that's going to be the ground. The highest we're going to go, well, we want to go a bit higher than the max. Max was 21, so we're going to go as high as 22. Going up by 1 is perfectly fine. We want to start off at 0 because it's time. We don't want to go past that. And it's 2 full rotations, so I'm going to go to 90 because 80 is too full. And I was going up by tens. So let's graph that. So syntax error. So I used a subtraction instead of negative. There we go. And my graph here, something went wrong with my window setting. Oh, I mixed my numbers around. So of course 0, our time here on our x going up by 10. And 0, let's go, I think we said 22, going up by 1s is perfectly fine. Let's try that one more time. There you go. And that looks a bit more proper. Sine curve, cosine curve, whatever curve you chose. We did negative cosine, so it works. So again, we're looking at how high above the ground after 15 seconds. So you want to find 15 seconds. So go trace, type in 15 seconds, hit enter, and there you go. That's going to be your answer, 18.07. So here for part C, we have 15 comma 18.07. So our height at 15 is equal to 18.07. Let's throw units on there. M for meters, and that one's good. D here, find the time or times multiple when your height is 15 meters when your height is 15 meters above ground. So how many times does that happen? So again, I'm going to go type in y2 here. Going to type in the 15. Hit graph. There you go. You have 1, 2, 3, 4, 4 answers that we're looking for. Go second trace, option 5, and we're going to find all 4. And I'm just going to find the first one and then list off all 4 answers because all 4 would have been the same. So I got 12.6 there, so that's going to be good. So our times would be, so again, we did y2 equals 15 there. So our times would equal, well, the first one was 12.6, the next one 27.4, third one would have been 52.6, and of course 67.4. And hopefully that matched up to what you got there. Our last question for today is this one here. This one's a bit of a tough one, by the way, because there's no real graph. We're given a table of values, though. Given a table of values. So it's saying on this is the average monthly temperature for Polson Town is in the chart below. So we have month 1 through 12, and of course that's from January through December 1 through 12 there. That's what that's corresponding to. And it makes sense here. Our temperature is negative 19, and let's assume that our temperature is in Celsius, let's say. Okay, so let's say our temperature is in Celsius. So in January, it makes sense that, yeah, we're at negative 19 degrees there. Hottest month, let's take a look. We got 17, 20, 19, 20 degrees in July there. Yeah, that seems reasonable. 18 in August, yeah, it's still also reasonable. Minus 14 there in December, yeah, that totally makes sense. So December and January were your 2 coldest months. Here it says develop an equation. So let's make an equation. Let's find our A value, our amplitude. So A is going to be equal to the absolute value of your max minus your min, all of that divided by 2. And of course, it's nice here, we do have a max and min, and I'm just going to point them out to you. So our maximum number here is going to be 20. 20 is our max number. Our minimum number, the smallest number we have, is right here, negative 19. So this is my min. Okay, so let's find our amplitude. So max min divided by 2, max is 20 minus negative 19 there, all divided by 2, and that of course gets us 19 and a half. That's going to be my amplitude. My displacement is equal to your max plus your min. So our max plus your min divided by 2, that's going to be your displacement, so that's equal to 20 plus negative 19 divided by 2, and of course that's going to be 0.5 or 1/2, however you want to write it. Our period, because we do have one period, and if you can imagine, this is as low as you can go. You're going higher, 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 peak around here, and then it starts to drop back down. So our period is, one full rotation is going to be 12 months. And of course we want a b value, so b is equal to 2 pi divided by 12, which of course reduces down to pi over 6. So that's going to be my b value. So what's our equation? We don't know what our phase shift is, and we can figure that out after. So let's just jot down our equation though. So we got it'd be, we can do something like y equals, okay, you could have used t, or even, yeah, let's use t because we got temperature instead. So t equals, oops, so we have an a value of 19.5. And again, if you're starting from a bottom, you went all the way up, and starting at another bottom here, so really quick sketch. So from the bottom going up back to a bottom, what kind of curve is that? Is that sine or cosine? Well, bottom to bottom, that's a cosine curve. So here we can use a cosine function. You know our b value is pi over 6. You have x minus, and let's call c just c there because we don't know if there's a phase shift yet, plus 0.5 for our vertical displacement. There you go. That's going to be our equation. Okay. And what you want to do is you could test this out right away to see if you need a c value, and if you type it in on your graphing calculator, let's see what we get. So right away on our graphing calculator you have the negative 19.5, and there's a reason why I said negative. Well, we're going from bottom to bottom, so it has to be negative cosine curve, not top to top. Cosine of, and here we're looking for pi over 6. Oops, let's try that again. Pi divided by 6, bracket, and again this time, this first one, we're just going to throw an x by itself there, plus 0.5, and there you go. That's going to be our graph. Y2, let's just clear that off. We didn't need any of that. And of course our window setting, we want something reasonable, so between 0 and 12 for our x going up by 1 month at a time. Our temperature, the lowest was minus 19, the highest was 20. So I'm going to go from as low as negative 20 to high of, well, let's go a bit higher than 20. So 22 actually does work. Going up by 1 degrees also works as well. Let's hit graph. So there you go. That's our function. Let's go second graph, bringing up our table value. Do our numbers kind of match up? We don't have a month 0. We have a month 1 at 16. Month 0 was at negative 19 though, so interesting. At month 2, we're at negative 9, but really month 2 on our chart here was negative 16. Month 3 was about negative 8, but we're at negative 9. So right now I'm slightly on, slightly off our numbers here. So what you want to do is, yeah, we definitely have a phase shift, and you probably want to start shifting your graph by, like, let's start with shifting it by 1 month. It looks like we're only off by a month. So if you go second graph again, At 0, again, we don't have a month at 0, so I'm going to scroll down there, get rid of it. Right now we're at negative 19. That does match up. Negative 16 matches up. Negative 8 versus negative 9 on our calculator. Slightly off. This one really off because we had 3. This is 0.5. 10 versus 11, close enough. 17 is almost bang on there. 20 for July, nice. 17 for August, we had 18 on our chart there, that's close. In September, we have 10 here on the graphing calculator. We have 12 on the chart, again, close. October was 6, and we have zero point 0.5, so our October numbers are off. November is slightly off, and December we're slightly off, but we are pretty much close enough on all accounts that if I hit graph, this is going to be my curve. There you go. So I did incorporate in a phase shift because it does match up and it makes our graph here make a bit more sense. I'm just going to leave our graph there on in our notes there in case you ever need it. And again, I did a phase shift of about 1 month. And the way that you're going to figure out your phase shift is you will have to test and see what your equation gets you. If you shift it by 1 or 2 months, that's perfectly fine. And in our case, it was 1. So we have x minus 1 because we're going 1 to the right. And there we go. Use the model to predict the temperature in October, and of course, October, let's go to our month of October. So go trace, go 10 because October is the 10th month. Hit enter. On our graphing calculator, it's saying that in October we're about, on average, half a degree Celsius. So I'm just going to quickly jot that down, and then that finishes off our question. So I'm going to jot down 10 comma 0.5. So again, the 10 represents October, and that 0.5 is our temperature in degrees Celsius. So that's our average temperature. If you have any questions about today's lesson, please feel free to ask.